Hello and welcome to video 4 of the Intro to SPSS 26 on AU apps. In this video, we're going to talk about how to run a correlation, create a scatter plot, run a simple OLS linear regression, run a multiple OLS linear regression, and then talk a little bit on how to export all your output out of AU apps and onto your local machine. Copy and paste does not work. So I'll walk you through how to do that. So going back to our data set and our output, we left off with running an ANOVA. So now what we're going to do is we're going to talk about questions of the relationship between continuous variables, because our recoded corruption variable and GDPPC are technically both continuous variables. Here we're trying to determine the relationship between GDPPC and perceived corruption, leaving corruption on its original scale from 0 to 10. The most basic graph for continuous variables is called a scatter plot. The scatter plot will show us that the two variables appear to be related. We will follow this visual intuition up with two tests. First is a correlation test to tell us the relationship between these two variables. A correlation close to 0 indicates that there is no relationship. A correlation close to 1 or -1 indicates that the relationship is very close to a perfect straight line. If it's 1, it's a positive relationship. If it's -1, it's a negative relationship. Then we're going to run a regression to tell us the nature of that regression line or the equation, which is a line defined by a slope, rise over run, and an intercept. The output for the regression will tell you if those are significantly different from a coefficient of 0. So to start, what we're going to do is we're going to create a scatter plot. Go to Graphs, Legacy Dialogues, and then scroll down to scatter/dot and click on that. We're going to click on Simple Scatter, and then click on Define. And I'm going to go ahead and right-click in here to display variable names. I'm going to move our corruption 2 onto our x-axis, our GDPPC to our y-axis. Then we go ahead and click on OK. This shows us the basic scatter plot. So we have our perceived corruption recoded scores on the x-axis, our GDPPC scores on the y-axis. In each country is a dot. Notice there's a lot of dots here close to this bottom part of GDPPC, so potential floor effect. And if we draw a line, let's kind of superimpose a line here, it looks like it's a negative relationship. Now what we can do then is if we double click the graph, that's going to open the edit. And then if you look over the fifth icon in this bottom part of it, add fit line to total, or add total. If you click on that, that's going to superimpose the regression line. If you close out of here, that's actually our equation that we haven't run yet, but that's the line that we have. So then I can actually kind of see what that line would look like if we ran it. Now, we're going to go ahead and run the Pearson product moment, sometimes called Pearson R, or correlation coefficient, which is a measure of association between two continuous variables. The sign indicates inverse versus direct proportional relationships. So a 0 again is a non-relationship, while a 1 is a perfect positive relationship, and a -1 is a perfect negative relationship. So run a correlation. We're going to go ahead and click on Analyze, go over to Correlate, and then we're going to go ahead and choose Bivariate. I'm going to right-click here. I'm going to find our GDPPC value, and I'm going to scroll down and do a corruption 2 score. I'm going to leave this as Pearson because they both correlate, they're both continuous in nature, and I'll leave this as a two-tailed test because I'm not quite sure where I don't have a hypothesis if it's going to be positive or negative a priori. So I'm going to go ahead and click on OK. So it's a 2x2 cell. Only one cell is actually relevant. So these actually mirror images of each other, and this is just the relationship of the variable with itself. So we have 151 observations that had scores for both of these variables. We have a negative 0.89 correlation. That's a strong negative relationship. And comparing the null hypothesis that there is no relationship, given the null, there's a low probability, less than 0.001, so we would reject the null in favor of the alternative. Again, we are never testing the alternative hypothesis. Great, so there is a significant relationship between these. We can now run a regression. So to run a regression, what we're going to do is we're going to click on Analyze, click on Regression, and then we're going to go ahead and choose Linear. If you're using different types of output or out-dependent variables like a binary out variable or maybe multiple categories or ordinal, there's other options. For now, we'll just choose a linear regression because we have a continuous outcome variable. I'm going to go ahead and right-click in our variable view to get the names. I'll take our corruption 2, put that towards the independent variable. GDPPC is going to be at our dependent. And now I'm going to change a couple of options. Under statistics, I'm going to ask for descriptives in part and partial. And I'm going to go ahead and click on continue. So you can also do things like if you wanted to save the predicted values, save the residuals, look at potential outliers. These are all different options here too. We're not going to cover that though. And then we're going to leave these all alone too. So I'm going to go ahead and click on OK. This is going to give us some more information. So we have our overall test. This is our model summary. Our R is the same because it's a simple regression, only one predictor or independent variable, one dependent. Our correlation that we had before is the same as our R. When you have multiple variables or multiple independent variables, that's going to change because you have potential multicollinearity. Our R squared is the variance accounted for. So we're able to account for almost 80% of the variability in GDPPC by including perceived corruption recoded in the model. This is our omnibus ANOVA test, which is actually our omnibus regression test. ANOVA, t-test, regression, it's all the same thing. It's all part of the general linear model. So you can actually run a t-test in a regression. You can run an ANOVA in a regression. The regression, multiple regression, is the workhorse of the general linear model. Based on this, our overall regression is statistically significant based on our F and our P value. And then we want to spend some time looking at our coefficients. We have our unstandardized coefficients, which is essentially in the raw metric. So knowing nothing about perceived corruption for a country, our best guess is that the country would have a 39,000 roughly. For each unit increase in perceived corruption, so going from a 1 to a 2 or a 2 to a 3, there's a reduction in GDPPC by 4,761 points. If you look at the standardized coefficient, now there's no constant here, there's no intercept, but for each unit increase in perceived corruption, for each standard deviation increase in perceived corruption, there is a negative 0.989 decrease standard deviation in our outcome variable. These coefficients are statistically significantly different from 0. And we'll talk a little bit about the part and partial correlations next. So this is a simple regression. If we were to write out the equation, GDPPC equals our interest or constant plus our negative 4761.49 times corrupt 2. That's our equation. Now we can extend this to a multiple linear regression by going to Analyze, Regression, Linear, and we can add literacy to an independent variable and click on OK. So now we've added another variable here. It is still statistically significant. Our variance accounted for is a little bit lower, but because we have more than one independent variable, we really want to use adjusted R squared. This accounts for the number of predictors within your model to reduce bias. So looking at our coefficients, our constant, it's a little bit lower for intercept because we have a better idea of what the intercepts are given what we have in our model. Our corruption score, it's not as sharp as a reduction. It's still pretty hefty though within there. So it's a 3,500 roughly reduction. It is statistically significant. And literacy rates, for each unit increase in adult literacy, the GDPPC goes up by 0.9569 points, which is pretty good. We also have our partial and part. So these are partial correlations. If you square the semi-partial correlation, that's the amount of unique variance accounted for. That's an interesting way of handling multicollinearity. Now, one thing we can't do is we can't copy and paste this because when we copy it and put it into a Word doc on our local machine, it's not going to work. So what you want to do is once you're done running this, you want to go ahead, if you want to save this as a PDF or as a Word, you want to go to File in the output window, click on Export, and let's say we want to do this as a Word doc. Now what I do is rather than the C drive, I'm going to change this, because we're on the Azure cloud right now. I'm going to go find our Z drive here. The Z drive is your local machine. From there, I'm going to find our desktop, and I'm going to go ahead and call this SPSS 26 output, and click on Save. And that's where it's going to, so it's going to be on our Z drive, so that's where we're saving it. Do not save it anywhere outside of the Z drive. If you save it on the Azure cloud, it will get erased. So make sure you save it on your local machine. I'm going to go ahead and click on OK. And now it's actually exporting that. I'm going to go ahead and save it also as a PDF. I'm going to click on Export again. I'm going to change Word to PDF. I'm going to leave it as a Z drive, but it's going to be a PDF file instead, and click on OK. And that's going to take a little bit of time for it to collate, but it's doing that right now. In the meantime, I'm going to switch back over to our data set because we've made changes to it. Oops, I have to wait for it to finish. What we're going to also do, because we've updated our data set, we're going to save a new copy on our local machine. Just going to wait for this to finish. Okay, it just finished. So I'm going to go ahead and I'm going to click back over to here. I'm going to go to File, Save As. And because we're still on our Z drive, so if I scroll over, see how it's Z drive and desktop? I'm going to go ahead and just click on Save. It's going to say, do you want to override it or replace it? Click on Yes. That way you have a new current version saved on your local machine. Again, not storing it anywhere outside of the Z drive. So what I'm going to do now is I'm going to go ahead and I'm going to close all the SPSS windows. Let me minimize this. Let me minimize this as well. And I'm going to log off of AU Apps. Let me get rid of that too. So now what I do is I'm going to go ahead and on my local machine, there's our data set we just saved to the desktop. We have all the output as a doc file. So if I open that up, here is all the output that we have on it in a Word doc, so I can actually copy and paste this into a report if I wanted. I also have the SPSS output as a PDF as well, with all the information that we've ran so far. I hope this was helpful and hope you have a great rest of the day.